In section 11.1, I don't want you focusing so much on the idea of angular momentum. What I really want you to get out of this section is the idea of the cross product and also associating a vector with any sort of circular object or torque or anything like that. So it's all based on the right-hand rule, which is a little discriminatory for people who are left-handed, but that's the convention that we've chosen. So if you have an object that's moving in, say, a counterclockwise direction, what you can do is if you take your fingers, like shown here, and curl them in the direction that the object is moving, your thumb then points in the direction of the vector associated with that circular motion. Like I said, this is a purely arbitrary choice, but that's how we represent circular motion or whatever. In our particular case, it's going to be torques. So if you have a force that's turning something in a counterclockwise direction, take your right hand, curl your fingers in the direction that the force is acting, and your thumb will show you the direction of the torque. So the equation for torque is R cross F. So this is the cross product. This is the second way that we're learning how to combine two vectors via multiplication. It's a special kind of multiplication for vectors. So to calculate the direction of this vector, what we do is, again, taking our right hand, point your fingers along the direction of whatever vector comes first. In this case, R is the first vector, it's the one right before the cross product symbol. Point your fingers in the direction of that vector, and then curl your fingers in the direction of the second vector, in this case, force. Then your thumb will be pointing in the direction of the resulting cross product. So you remember with the dot product, we end up with a scalar quantity. With the cross product, we end up with a vector quantity. And one thing to notice is that the vector that results from the cross product is actually perpendicular to both of the original vectors. Okay, point that out again. R is along this direction, F is along this direction. The cross product is perpendicular to the plane defined by these two vectors. So that's always true. When we take the cross product, the result is always going to be perpendicular to the other two. Now, in terms of calculating it, the book shows two ways. This determinant right here is kind of a shortcut for figuring out the vector in terms of the components. You don't need to do this. In the little blue box on page 419, they actually show the different components, but you can figure out using determinants how what form the cross product has. So I hat, j hat, and k hat. These are the unit vectors along the x-axis, y-axis, and z-axis. And so if we just go ahead and add up the product of components slanting down from left to right, and subtract the products we get from multiplying from right to left, we'll end up getting the right equation for the cross product. So let me just kind of walk you through that. So the first term comes from multiplying these three together. So we get I hat, AY, BZ, and let me just take the other diagonal, and when we're going down from right to left, we subtract. So this is going to be K hat AY BX. Now let's take these three. When I get down here, I need to wrap around to the other one. So plus J hat AZ BX, and minus, going this way, J hat AX, and then that wraps around here, BZ. And then the only thing that is left is, let's see, K hat AXBY, and then minus, starting here, wrap around like that, minus I hat AZBY. All right, so I should end up with two terms for each unit vector. And so let me just go ahead and combine these. So the I hats, that's giving me my x component. So if I write this in vector notation, AY BZ minus AZ BY, my x component. J hat is my y component. So AZ BX minus AX BZ. And then the Z component is the K hat AX BY minus AY BX. So that's one way of figuring it out using this determinant here. What I want you to concentrate on, though, is making sure you know how to calculate the cross product if you're given those two vectors. How do you go about calculating it? And if you're given the two magnitudes and the angle between them, how would you go about calculating the cross product? So again, don't focus on the stuff dealing with angular momentum. Focus more on how to calculate the cross product of two vectors.